In this video, we're going to talk about joint variation and combined variation. So let's begin with a few examples. We say that y varies directly as the square of x if y equals kx squared for some positive constant k. Now, we could also say y varies directly as the cube of x if we had y equals kx cubed, and so on. We say that y varies inversely as the square of x if y equals k over x squared. And we say that y varies jointly as x and z, so notice here we have three variables, y, x, and z, if there's a positive constant k such that y equals kxz. Okay, that's joint variation. Now in each case, the k is called the constant of variation. So let's look at an example. The area of a circle is given by this familiar formula, a equals pi r squared, where r is the radius of the circle. But notice here that a varies directly with the square of r, with r squared. What is the constant of variation? Well, the constant of variation, the k, is pi. Okay, a equals k pi squared. So a varies directly with the square of r. Let's look at another example. Suppose y varies directly as the square of x. So let's write out the equation here. Y equals kx squared. And that y equals 75 when x equals 5. Find the constant of variation and an equation of variation. Okay, so let's plug in 75 for y and 5 for x. And notice that we get 75 is equal to 25k. And so k is equal to 3. So our constant of variation is 3. And our equation of variation is y equals kx squared, but the k is 3. So it's y equals 3x squared is our equation of variation. Lastly, find y when x is 7. Well, we just need to plug in 7 for x here. And so we get y equals 3 times 49, which is 147. Right? 3 times 50 is 150, so 3 times 49 would be 3 less than that, 147. Okay, let's look at another example, this one with joint variation. Suppose y varies jointly as x and z. So our equation is going to be y equals kxz. And that y equals 120 when x is 3 and z is 5. So find y when x is 7.5 and z is 4. Okay, so let's plug in what we have here. We have 120 for y, and for x we have 3, and for z we have 5. So notice we get 120 is equal to 15k, and so k is equal to 8. 120 divided by 15 is 8. So k is our variation constant. So our equation is y equals 8xz. Okay, because it's kxz, but the k was 8. And so finally, let's find y when x is 7.5. Let's plug in 7.5 for x and 4 for z. Okay, so this would be y equals 8 times, now 7.5 times 4, that would be 30. And 30 times 8 is 240. Okay, so the answer is 240. All right, let's look at another example. And this one we aren't going to have numbers, but it just asks for an equation of variation. Find an equation of variation in which y varies jointly as x and the square of z, and inversely as the product of m and n. Okay, so what is our equation of variation? Well, y varies jointly as x and the square of z, so it's going to be kx z squared, and inversely as the product of m and n, so we're going to divide by m and n. Okay, so k is our variation constant, but y varies jointly as x and the square of z, and inversely as the product of m and n. Now let's look at one more example. The braking distance d of a car after the brakes have been applied varies directly as the square of the speed r. Now notice this kind of makes sense. The faster a car is going, the longer it's going to take to stop, right? The greater the braking distance. Now it's not that d varies directly with r though, it's that d varies directly as the square of r. Okay, if a certain car traveling 65 miles per hour can stop in 325 feet, how fast can the car travel and still stop in 100 feet? Round your answer to the nearest mile per hour. Now notice if a car going 65 miles per hour takes 325 feet to stop, and we want to be able to stop in 100 feet, well, the car is going to have to be going less than 65 miles per hour. So we expect our answer to be less than that in order to be able to stop in only 100 feet. Okay, so let's do this problem. D is equal to K R squared. Okay, the D varies directly as the square of R. So if we plug in 65 miles per hour for R and 325 feet for D, what do we get? Well, we have to square 65, and you get 4,225 if you do that. And we have 325 here, so we get K is equal to 325 divided by 4,225. Now, you could divide this out in a calculator and get a decimal. It turns out, though, that this fraction actually just reduces to 1/13. If you take 4,225 and divide by 325, you actually get 13. Okay, so what is our equation now? Well, we have D is equal to 1/13, right, K, R squared. And so the question is, how fast can the car travel and still stop in 100 feet? Right? So if the D is 100, what is the R going to be here? Okay, well, we have 100 equals 1/13 R squared. If we multiply both sides by 13, we'll get 1,300 is equal to R squared. And so R equals the square root of 1,300, which if you use a calculator, you will get, let's see, I got 36.0555128 ... Just some decimal that goes on and on forever. So this is approximately 36, and that would be miles per hour.